Section 7.2, multiplying and dividing rational expressions. So an expression is something like this. There's no equal signs. There's no two sides like an equation. An expression is just something without an equation like this. Variables and numbers. Okay, so we're dividing and multiplying. This is multiplication first. So multiply. So when you're multiplying rational expressions, or the rational part would be fractions. So that's one way to think about rational. Think is they're always in a fraction like that. Expressions is everything. All right. So when you multiply, you just multiply across. But sometimes you can eliminate stuff, or things can become one either vertically or diagonally like that. You can when it's multiplication, because when it's division, you have to do one step before you can do that, an extra step. But when it's multiplication already, you can cancel. I know you guys like the word cancel, eliminate. I'm gonna use cancel just so that you guys, because I know you guys are familiar. You can simplify vertically or cancel diagonally or vertically like this. So this one, you can't really do anything. So all you have to do is multiply across. So 25x times 1 would be 25x over, and then 2 times, there's a 1 here, so 2y cubed. And that's it. You can't really simplify this, so that would be the answer. Same here. Before you can do anything, you can do stuff. Like I said, you can get rid of stuff diagonally. If you notice, this is x squared. So let me use another. You can eliminate this one with this one. They would become 1. Even though it's diagonally, you can do that. And then this way, you can get rid of this one. And this one would become 4. Y to the 4. And also the numbers, I just noticed 7 and 14. So some students, when they see this, for some reason they want to put the 2 on top. So when you simplify this is like this, right? So 7 over 14 would be something like this. Even though they're in a different position in the expression, they're still this. So you can simplify by dividing both by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. So 7/4 is 1/2. If you notice, the 2 is at the bottom. I'm saying this because I've seen students, they have this and they give me this, like the opposite. So this is wrong. So when you're simplifying these two, you can actually, so that would become a 1, right? Like I did here. And this would become a 2. And maybe I should have put everything together. It would have been easier to see, but I'm just doing it from the beginning. So now it's a 1. We don't have that anymore. We have the negative, and we have the 3. So 1 times 3, you multiply across. So negative 3, and then the y4. For the next one, I'm going to put everything together because it's hard to see when you do it like this. But if you get good at it, you don't have to put anything together. You can cancel from the get-go, or eliminate, or simplify. And then here we got rid of that y, right? With that y to the 5th, we went to 4, and then that one we got rid of it. It became 1. So now 5, the 14. Remember with the 7, now it's a 2. So 5 times 2 would be 10. And then the x's, we don't have them. So this is it. There's nothing else you can do with it. That would be the answer for that one. Alright, and it's negative. You can put the negative here, right next to the division, or you can leave it here. It doesn't, most of the time they put it here. Alright, so this one changes because now we have a plus sign here, and we have a plus sign here. So this type, the first thing you need to think of, can we factor something from here? Or GCF, you guys can we do the same to this one? And the answer is yes. So this one, look, you guys, I'm gonna put it like this. This one you can factor, I'm gonna do it like this, you can factor in x, and then you still have the 3x, and then this one 5x plus 5, so times, you can still do the 5. So what happens here, we're gonna have the x, right? This is the GCF. I'm just giving you an extra step. I wouldn't do this, but I'm just showing you what happened. So you would pull out the x, what's in the middle, so in the parentheses, x squared divided by x is just x. X or x would be 1. So this is that part. And then you have the 3x, this one. And then times 6 over, and then what happens here? So you see as a 5, so the 5 is outside now. And then 5 over 5, and then you just have the next day, this one become a 1, and then 5 over 5 is just 1 again. So this is what is here on this position. So now, you know, think about stuff that you can get rid of here, diagonally or vertically. So these two are the same. X plus 1 is the same as x plus 1, and it's a product now because it's multiplying. So now you can eliminate those, or those become 1. Alright, I'm going to rewrite it. I'm not going to do the 6 and the 3 yet. So I'm going to do x over 3x times 6 over 5, right? We got rid of that. So this, if I put it together, let's put it together. 6 times x is 3x times 5, right? I'm going to do it this way now. If you notice the 6 and the 3, you can simplify them and the x's. So what's going to happen to the x's? They become 1. What happens to the 6 and the 3? What's 6 divided by 3? It's 2. So you would have, so that one becomes a 1. And that one becomes a 2. Now, so you have 2 at the top. You got rid of these 2. And you have 5 at the bottom. And that would be the answer for this one. Alright. So these are just steps. I'm just going to show it to you guys for multiplying rational expressions. Step 1 would be completely factor numerator and denominator. So now the next examples, you most of the time you would have to factor first before you can start eliminating stuff, right? Second step would be multiply numerators and multiply denominators. So they like doing it like this, where they connect everything before they cancel. That's fine. Or you can eliminate before or after. It's up to you. But I'm gonna try to do it like they're doing it in most cases. And then step 3, simplify or write the product in lowest terms by dividing out common factors. So this is at the end. That's when you simplify. If it's the same thing, they become 1, or if it's 6 over 3, you get a 2 at the top and you get a 1 at the bottom. That's what they mean, simplify. Lowest terms. So this is example 3. So in example 3, so the first thing is factor. So factor, that's the first step. Can you factor something from here? Yes, you can factor a 3. So 3, so what's happening? You're dividing this by 3 and that by 3. So 3 over 3 goes away, so you got the x, and then 3 over 3 just plus 1. So we factor this one. Oh, GCF, you guys know it as GCF. Greatest common factor. This one, we can actually factor out a 5 and an x. So 5x, so greatest common factor, we're still factoring. So 5 over 5x is just 1 here. And then 5 over 5, so that eliminates, so you get a 1. That eliminates, and then x squared over x, so that's a minus. Don't forget the minus, and then 2x is here and 1x, you get 1x here left. So why 2 minus 1? There's a 1 here. So that's how it looks. And then let's see if we can factor this one. And this one also. This is going to be this type of factoring. So these were GCFs. This is the actual factoring that we've been doing, and if you notice, this is greater than 1, so this is a AC method. I'm not gonna solve by AC method. I'm just gonna put the answer here because I don't want to take that long. So I know this is gonna be 2x plus 3 when you factor this one, x minus 1. These are the factors of this part. And then for this one, this is, if you guys notice, this is a difference of perfect squares. So that means you're gonna have 2x minus, remember, 3, 2x plus 3. So remember, this is this one, a plus b, a minus b. Here's what we got, minus, plus, so plus minus, it doesn't make a difference. Okay, once we get to this step, that's when you have to see what can you simplify. If you guys notice, these kind of look the same. Not entirely so. We can actually change that one so that it looks like this one. We could have factored a negative 1 from here. We should have done it from the beginning. We should have GCF a negative 5x, and that would have changed the signs here, but we didn't know about this one until now. So now you have to do it. So we factor a negative 1 in this one. So I'm going to copy this one again here. So we're factoring a negative, so you get 5x. So that negative is going to be outside, so I'm just going to put a negative. And then inside, this would become a negative, and this would become a positive. So this would become a negative 1 and a positive x. And I'll leave it like this so that you know what I mean at the end. Even though I have to do extra writing, I want you guys to see what happens. So yeah, it still doesn't look the same, but if you notice, that's a negative 1, that's a positive x, that's a negative 1, that's positive x. So we can change around these things. So remember, commutative, associative properties, those properties give you the liberty of changing this around. It doesn't affect the outcome. So I'm going to put it like this. Again. And you don't have to do this many steps. If you notice that, if you can simplify from the beginning, that's good. So this one, I'm going to put the x first and then the negative 1 second. So now if you notice, they look exactly the same. So you can simplify these, they become 1. 2x plus 3, there's 2x plus 3 here, so you can simplify these ones. And just keep everything that you have left. So it would be 3x, the 1 over here, and then you have the negative. So I'm going to put the negative here. Like I said, you can do that. And then I'm going to put the 2x minus 3 here. And that's the answer. That's example 3. Let me see. I don't think I'm gonna get to, maybe I'm gonna do maybe these two because then the video is gonna be too long. So this is where you divide. So dividing. So before we do anything, you guys can think about, you can do the keep, change, and flip. On the book, I don't think they do that, but it would be a good option to do. Let me see. Yeah, they are. So this is what you do here. To get rid of that division, you would keep the first one somewhat. So you keep, and then you change this, and then you flip this, and this is how it looks. So you keep this one, the first one. This one you change it to a multiplication, and that one you flip it. So now it's a multiplication instead of a division. So now we can start thinking about what can we simplify diagonally or vertically. But let's put everything together first. Let's see how that looks. So 3x cubed, so I'm multiplying across like that. 3x cubed, there's nothing here to combine it with. And then y7 times y to the second power, that would be y9, right? You add 7 into 9. And then you multiply across. So 40 times 4, let me simplify that. So 4 times 4 is 60. 16, so 160 times the x cubed. Alright, so what happens here? That's when you start to see what you can simplify. You can simplify this, it becomes a 1. And then I think this is divisible. Let me check. Let me see if you can simplify. Nope. So for example 4, that would be the answer. So just put everything together. So 3y9 over 160. And I thought it was I thought this was, you could simplify because of the 6, but yeah, I was wrong. So that would be the answer for this one. Okay, number 5. So again, yeah, you see the division, so let's get rid of it. So I'm gonna write it again, the keep, change, and flip. So you keep the first one, and then the first one, if you guys notice, so this means you're multiplying these twice, and I'm just gonna separate them now. So this means these are equivalent, what I'm about to do here. So this and that is the same because you have 2 of this. That's what that 2 exponent tells you, that you're multiplying the base twice. And then you have a 10, and then you change the division to multiplication, and then you flip this one. So the 5 now is on top, and then the 2x plus 4 at the bottom. So let me copy them again. Times 5. And then if you notice, so every time you need to see if you can GCF or factor. We can factor 2 from this one. So you have a 2 outsides, 2 over 2, you end up with 1x, 4 over 2 would just be plus 2. And then the GCF goes outside. So now let's put it all together. That way you see what's going on. So 5 times all of this. So this is just, do not distribute because the purpose of this is to cancel or simplify everything. If you distribute, then things change, and then you don't see what you can simplify. 10 times 2 would be 20. And these numbers I can't, because I know this is going to be, you can simplify this. And then you put the x plus 2. And then this is when you start simplifying. So x plus 2, so you can get rid of one of them. 5 over 20, what is it? You can divide by 5, so this becomes a 1. And this becomes, so 20 divided by 5 becomes a 4, so 1/4. So on the top, you are left with x plus 2 over 4. Everything else was simplified. And you can write it without parentheses in this case, because there's nothing besides like next to it, so you can take out the parentheses. If there was a number here, you couldn't, but since we don't have anything, you can put it like that. Or you could have leave it like that, I would have given you credit. Okay, let me see if I can try and do this on number 6, the last one. Alright, so number 6. So we're dividing again, so let's do the steps. So we're gonna keep. We're gonna keep this one. We're gonna change that to a multiplication. And we're going to put that, we're gonna flip this one. So now let's see if we can factor GCF something. So from this one, we can GCF a 2. So I'm gonna put it here now. Times and then like that. So from here you're gonna have the 2 outside. 6 over 2 is 3, and then the x, and then 2 over 2 is just 1, so plus 1. Here you can actually, this is a difference of perfect squares, minus 1 square is just 1, so this, it's a difference of perfect squares. So you can have x minus 1, x plus 1. Let me see, yes. And then here you have x minus 1, and then here you can you can take out an x. So you would have x, so 3, and then x, and then plus 1, right? X over x. So now let's put everything together. 3x plus 1. So now we're multiplying across like that. And then put this in parentheses, x minus 1 over, and then all of this stuff. So I'm going to put the x in the front, and then I'm going to put x minus 1 here, and then x plus 1 here, and then 3x plus 1. And then you start simplifying stuff, so you can simplify this, you can simplify that, and whatever's left, that would be the answer. So we're left with 2 on the top, with the x at the bottom, and that x plus 1 at the bottom. And that would be the answer. Let's see why, what is example 6? Yeah, that would be the answer. And I'm gonna stop right there because I don't want to go too long. Thank you guys.